The world is breaking its own rules over and over again somewhere out there. Space isn't just big, it's also violent, strange, and much stranger than fiction. Stars spin so fast that they almost tear themselves apart, and explosions shine brighter than whole galaxies. We're gonna look at some of the strangest things that have ever happened in the universe. GRB 200826A, the Identity Crisis Burst. Scientists have a set of rules for gamma-ray bursts. People think that the short ones, which last less than 2 seconds, are caused by neutron stars smashing into each other. Long ones lasting more than 2 seconds normally happen when a very large star falls apart and turns into a black hole. However, in August 2020, something called GRB 200826A broke those rules. This burst lasted only 0.65 seconds, which would normally make it a classic short gamma-ray burst, but as scientists looked deeper into the data, things got weird. This confused astronomers around the world and they nicknamed it the Identity Crisis Burst. Swift J1820+070, the hybrid star. In March 2020, astronomers detected a cosmic oddball that instantly shook up our understanding of neutron stars. Magnetars are already wild. They have magnetic fields up to 1,000 trillion times stronger than Earth's. That's so powerful it could erase your credit card from halfway across the moon. But the hybrid star was even weirder. It spun once every 1.36 seconds, which is very fast for a magnetar. The hybrid star also started emitting radio waves, something only a few magnetars have ever been seen doing. GRB 090423, the ancient flash. On April 23, 2009, telescopes caught a brief but blazing flash of gamma rays that came from 13.1 billion light-years away, and even though the burst itself lasted less than 10 seconds, it had already traveled for over 90% of the entire age of the universe before reaching Earth. The light from the ancient flash began its journey just 630 million years after the Big Bang, a time before galaxies were fully formed, before heavy elements were common, and before the first generation of stars had even fully lived and died. The light had been redshifted to such an extreme degree that its signature lines had been stretched by the expansion of the universe more than ever recorded in a GRB. A redshift of 8.2 means the universe was 9 times smaller back then. Earth didn't exist. The sun hadn't been born. SN 1054 Crab Nebula, the Daylight Supernova. Picture getting outside one morning and seeing a brand new star that is so bright you can see it during the day. Native American rock paintings, Chinese scientists, and Japanese monks all wrote about a blinding point of light that showed up in the sky. That event in space is now known as SN 1054 and can still be seen in the sky as the Crab Nebula. The centerpiece of the nebula, the heart of this story, is the Crab Pulsar, a neutron star just 20 kilometers wide, spinning 30 times per second. This object is one of the most powerful known natural particle accelerators in the universe. When scientists want to check if their telescopes are working properly, they often point them at the Crab Nebula. Maxi J1820+070, the jet gun. Black holes are often thought of as silent eaters that take in matter and never make a sound. And one of them, Maxi J1820+070 shot matter jets at speeds close to 80% the speed of light, making it look like a cosmic machine gun. Powerful magnetic fields anchored in the spinning accretion disk tap into the rotational energy of the black hole itself. One jet appeared to be moving faster than the other, but that's an illusion caused by relativistic beaming. Astronomers were able to get a good look at the released jets by using very long baseline interferometry. Further observations revealed X-ray echoes, reflections of the blast bouncing off the gas around the black hole. GRB 130427A, the eternal afterglow. On April 27, 2013, a gamma-ray burst lit up the universe in a way we had never seen before. Gamma-ray photons with energies of up to 95 billion electron volts were caught by the Fermi sensor. Most gamma-ray bursts die out quickly, but the eternal afterglow refused to die. The eternal afterglow came from a Wolf-Rayet star, a massive hot star stripped of its outer hydrogen layers teetering on the edge of collapse. The most powerful particle accelerator on Earth, the Large Hadron Collider, maxes out at about 13 TeV. This burst casually beat that. We learned that the jet was very stable and had very little internal scattering. PSR J0952-607, the cosmic blender. It can take days or even years for most stars to make one full turn. This pulsar spins faster than any other known pulsar in the universe. at an amazing 707 times per second. Over billions of years, that companion dumped gas onto the neutron star in a process called accretion. The pulsar is essentially vaporizing its partner. It's been so thoroughly cooked, eroded, and blasted by radiation. The outer centrifugal force would actually tear it apart if it spun much faster. This makes it a natural laboratory for testing the equation of state, the rules that determine how matter behaves at nuclear densities. Swift J1820+070, the zombie star. A lot of stars stay dead after they die, but Swift J1820+070 wouldn't do what was asked of it. It died, but it kept coming back once more. A star got too close to the black hole at the center of the galaxy. The star was ripped apart by the strong tidal forces. It was torn apart like paper going through a cosmic shredder. Instead, it spiraled into an accretion disk, a swirling funnel of gas and stellar guts, feeding the black hole bit by bit. And in a rare twist, the black hole launched a jet of material directly at Earth, allowing us to observe the entire feeding frenzy in real time. This made the zombie star the first tidal disruption event we could watch in real time, a cosmic feeding frenzy that redefined our understanding of how black holes consume matter. These are the universe's most extreme rule breakers, pushing the boundaries of physics and challenging everything we thought we knew about the cosmos.